You know that feeling, right? You're engrossed in a really long article or maybe a complex report, and by the time you reach the end, you realize you've vaguely forgotten that crucial detail from the
Oh,
beginning.
definitely. Or maybe you just totally missed something important buried deep in the middle.
Exactly. Now imagine that exact struggle, but for an AI, that's what we call the long context problem in the fascinating world of large language models.
And it's more than just like an inconvenience. It's a fundamental challenge. It currently limits the potential of these really powerful AIs.
How so?
Well, think about how we humans connect distant pieces of information. We retain context across enormous bodies of text, drawing on our long-term memory, our accumulated knowledge.
Right.
For a truly intelligent AI, what some call artificial general intelligence, AGI, to reach its full potential, it needs that same ability. It needs to comprehensively understand vast amounts of information. But LLMs often hit a frustrating wall here.
And that wall leads to some serious practical issues, doesn't it? We've
Yeah.
all heard about AI hallucinating, making things up, or
Mhm.
simply overlooking critical information because their context window is just too small to see the whole picture.
It's like giving an AI a keyhole view of a massive library
Hmm.
and expecting it to understand every book.
Yeah. And forget trying to train these models for super long contexts. The computational cost is just, well, astronomically high.
Exactly.
So when you mention fundamental challenge, what are the real-world consequences of LLMs hitting this wall? Is it just slower results, or does it become financially unfeasible for companies to deploy these models effectively for complex tasks?
You've really hit on the critical point there. It's not just about speed. It's about accuracy, reliability, and ultimately utility.
Utility, right.
When LLMs can't grasp the full context, their usefulness for complex tasks like, say, legal review, scientific discovery, or even just detailed customer support is severely hampered.
Okay.
And it is financially impractical to constantly fine-tune models on ever larger contexts. Current efforts to address this fall into a few categories:
Mm.
tweaking training data, designing new architectures, or, what we're focusing on today, workflow-based methods. These often involve agent-based systems.
Agent-based systems, like
Mhm.
having a team of mini AIs each handling a part of the task.
Pretty much, yeah. Almost like delegating sections.
Which sounds incredibly promising on paper, a classic divide and conquer strategy.
It does.
But from what I understand, previous agent-based methods have their own Achilles heel. You mentioned prohibitive accumulated latency,
Right.
which for us listeners just means it takes forever, right? Because of all the back and forth communication between those mini AIs.
It can get very slow, yes. And even worse, you can get amplified information loss.
Ah, like playing a game of telephone.
Exactly like that, where crucial details get garbled or just lost in translation with too many agent calls.
Okay.
And if you partition the text immoderately, meaning, you chop it up without logical sense of where the natural breaks are,
Yeah.
you disrupt the natural flow.
Like trying to understand a novel where entire chapters are randomly cut out or reordered.
Precisely. It sounds like a lot can go wrong, including inter-agent misalignment, where the mini AIs just aren't quite on the same page.
That makes sense. It sounds like a real tangle of problems.
It has been. Those limitations have been significant hurdles, which really brings us to our mission for this deep dive.
Okay.
Today, we're unpacking a fascinating new approach to solve this, exploring a paper titled Long Context Scaling: Divide and Conquer via Multi-Agent Question-Driven Collaboration.
Right. So our mission is to truly understand how this novel framework, quite cleverly named Expanda or Expand Agent, is pushing the boundaries.
Mhm.
It's allowing large language models to process truly enormous texts. We're talking from 1,000 all the way up to 1 million tokens with surprising accuracy and speed.
Yeah, the scale's pretty impressive.
By the end of this deep dive, we think you'll have a profound new understanding of how LLMs are evolving and perhaps even some fresh perspectives on how you interact with AI, with some genuinely surprising breakthroughs along the way.
Hopefully some aha moments.
Definitely. So let's unpack this core idea behind Expanda. At its heart, it's a novel, multi-agent framework using a sophisticated divide and conquer method, but with some very significant upgrades.
Right, it's not just chopping it up randomly.
What's truly remarkable about Expanda, from what I'm reading, is not just what it does, but how it's designed. The paper highlights it's meant to be plug and play, robust, interpretable, and efficient. Now, from your perspective, why are those specific qualities so critical for a technology like this, especially if we're thinking about real-world adoption?
That's a fantastic question,
Mm.
because those qualities are exactly why Expanda stands out from previous attempts.
Mm.
Plug and play means it can dramatically lower the barrier to entry.
Okay.
It allows existing LLMs to gain these super context abilities without massive, costly re-engineering or retraining.
Which is huge.
Yeah. Robust is crucial because it implies it works reliably on messy, real-world data, not just clean academic data sets. That's where many systems falter. And interpretable is absolutely key for debugging, for understanding why an AI made a certain decision, and frankly, for building trust in these increasingly complex systems.
Trust. Yeah, that's a big one.
And finally, efficient directly addresses those latency and cost issues we just discussed. It has to be practical.
That makes perfect sense. So with those principles in mind, what's the actual workflow? How does Expanda break down this massive challenge?
Well, what really stands out about Expand is how it systematically breaks down the challenge. It's into 3 distinct yet interconnected stages.
3 stages, okay?
Yeah, and it's a workflow that genuinely mimics how, say, a human researcher might tackle a truly massive document or a sprawling body of information.
Okay, so let's jump into stage 1, dynamic partitioning. This sounds like where it gets smart right from the start. Instead of just rigidly splitting the text into arbitrary fixed-size chunks,
Right, which is the naive approach.
Expanda adaptively modulates how it breaks down those long texts into smaller, manageable pieces. How does that adaptive modulation actually work? What's it doing?
That's a key innovation.
Yeah.
So for shorter texts, it makes the chunk sizes relatively equal, which makes sense. But for those truly immense texts, we're talking up to 1 million tokens, the individual chunk size actually saturates. It maxes out at around 100,000 tokens, 102,400 to be precise.
Okay, hits a ceiling.
Exactly. Beyond that point, it's not the size of the chunks that continues to grow, but rather the number of chunks that increases dynamically to cover the full input.
Ah, I see. So more chunks, not bigger chunks after a point.
Precisely. And the cleverness continues because it also uses overlapping chunks.
Overlapping. Why?
Well, think about it. If you just cut text sharply, you might lose context right at the boundary. The overlap helps maintain that context flow across the chunk boundaries.
Like ensuring a story flows seamlessly between chapters.
Exactly. And that overlap size also adapts to the total length. It's all dynamic.
So for you, the listener, what this dynamic approach means is that Expanda finds an optimal trade-off, a balance between how fast each chunk is processed and the overall time it takes.
Right. It leads to what they call asymptotically optimal inference speedup.
Okay, plain English.
It means that as the texts get truly massive, hundreds of thousands, up to 1 million tokens, expanded speedup becomes increasingly pronounced and efficient. It scales much better than other methods that would just bog down.
It's thinking about efficiency from the very first step.
Smart.
Very smart. But then, once Expanda's dynamically partition the text, it doesn't just stop there. The next crucial phase kicks in, question-guided exploration.
Question-guided exploration. Okay.
Imagine little explorer agents diving into each of these dynamically partitioned chunks.
Right.
But they're not just passively reading, they're actively driven by specific questions.
This is where it really distinguishes itself, I think.
Yeah.
Each explorer gets its specific text chunk, the main query you're asking the system. And critically, a centralized shared memory. This isn't just a scratchpad, is it?
No, not at all. It contains existing question-answer pairs and also unsolved problems that other agents have found or flagged during their exploration. So it's like a shared knowledge base.
Exactly. As they process their chunk, these explorers actively decompose problems into smaller subproblems, search for information to answer those, and even generate new problems that might need further investigation in other chunks.
Okay, so if I'm thinking about a human analogy here, it's like a team of researchers all contributing to a shared document or whiteboard, constantly refining their questions as they uncover new information. Is that the right way to visualize it?
Absolutely. That question-driven protocol constantly updates that shared memory. It builds consistent inter-agent knowledge across partitions.
Which prevents that information fragmentation you mentioned earlier.
Precisely. It prevents the problem of each mini AI working in a silo. It really is like that group of researchers constantly updating a shared whiteboard with new questions and findings.
Ensuring everyone is working toward a common goal, filling in gaps, rather than just summarizing their individual sections.
You got it. It guides the LLM's attention intelligently.
Okay, that makes sense. And then, the final stage, you said it was really ingenious.
Yes. Stage 3. Iterative selective replay. This is where Expanda truly shines, in my opinion.
Why?
Because traditional chunking, even with overlap, can really lose interrelated information. Think about it. If a piece of information in a later part of the text depends heavily on something mentioned much earlier.
Like a flashback in a story, or maybe a legal precedent cited way back that becomes crucial later.
Exactly. That creates what the paper calls dangling nodes in the AI's reasoning chain. It just can't connect the dots across those large distances sometimes. That's been a huge limitation.
Right, the non-sequential dependencies.
Yeah, that's the challenge.
Yeah.
So after the explorers go through their initial pass of the text, a decider agent evaluates all the information that's been gathered.
Okay, a manager agent.
Kind of. If this decider determines that the information isn't sufficient to answer the main query confidently, it initiates a selective replay.
Selective replay. So it doesn't just reread everything.
No, that would be inefficient. It's much smarter. It meticulously tracks question information couples, essentially. Which questions relate to which specific pieces of information found so far?
Oh, wow.
This allows it to intelligently replay specific partitions, go back and re-examine specific chunks that are most likely to fill in the missing information or resolve those tricky dependencies.
Wow.
It can even perform a backward search to find earlier context needed for current reasoning.
So what does this all mean for you, the listener? This mechanism ensures that even complex dependencies are resolved. The overall understanding of the text is greatly improved, even when critical information is scattered or out of order.
Right. It's like the AI knows exactly what it needs to reread to get the full picture, rather than just blindly starting over or guessing which parts might be relevant.
This isn't just a technical tweak then. It feels like a fundamental shift. It allows LLMs to move from being impressive summarizers to genuine comprehenders of vast interconnected information.
Much like a seasoned human expert would approach a complex document.
Wow.
Yeah.
Okay, so the theory sounds great, very elegant, but the proof is in the pudding, right? Let's talk results. Expand and data, Kendron.
Definitely. The proof of concept really comes down to its performance, and the results are pretty eye-opening.
The paper details extensive evaluation across diverse tasks and what they call ultra-long sequences, ranging from 1,000 tokens all the way up to 1,000,000 tokens.
Yeah, a massive range.
Yeah.
And the tasks included question answering, both multi-hop and narrative styles, information retrieval, code tasks, and even graph reasoning. So a good mix.
And how did it stack up against the competition?
In terms of outperforming the competition, the numbers are indeed impressive. Expanded demonstrates on average 20% improvements in overall performance.
20%, that's significant.
It is. And a 1.5x inference speedup over strong baselines. This isn't just a minor improvement, it's a substantial leap forward in practical usability.
That truly is impressive. Are there any specific types of tasks where this speed up or performance jump is most pronounced? Or maybe where the challenges were previously so great that even a 1.5x speed up is still not quite enough?
Well, the speedup is particularly impactful in those ultra-long context scenarios, precisely where traditional models would just bog down, or worse, truncate the input.
Right, just chop off the end.
Yeah, inherently losing information. So crucially, Expanda consistently outperformed full context models that do that truncation.
Okay. And what about RAG, Retrieval Augmented Generation?
It also surpassed RAG systems, especially in multi-hop tasks. You know, those questions that require gathering information from multiple places in the text and then reasoning across them.
Our RAG struggles there.
It often does, yeah, because it typically retrieves relevant snippets, but doesn't inherently have this strong mechanism to iteratively retrieve and reason effectively across potentially fragmented pieces from different parts of a very long document.
Gotcha. And compared to other agent systems?
What really stands out here is that Expanded significantly outperforms even previous agent-based methods like chain of agents, CoA, and long agent
How so?
in both success and progress rates. This means it's not just getting better final answers, but it's also better at purposefully acquiring the right information along the way and efficiently solving those tricky multi-hop problems.
It sounds incredibly robust. But was there any scenario where this dynamic partitioning could actually miss crucial information? Like by making an adaptive choice that turns out in hindsight to be suboptimal for a specific query?
That's a perceptive question. And the paper does acknowledge one interesting exception: the GraphWalks dataset.
GraphWalks, what happened there?
ARIG actually performed best there, but only with one specific LLM used in the tests. And the paper's theory for this is quite insightful.
Ooh.
The text in GraphWalks is highly structured, like node-node connections, often with specific hexadecimal hash strings.
Very pattern text.
Exactly. That highly structured, predictable format might allow RI's retrieval mechanism to pinpoint information more precisely. using keyword matching, essentially. Maybe even better than Expanda's more semantic, attention-based approach in that one specific case.
Interesting. So it shows that context matters, and sometimes simpler retrieval works for simpler structures.
Right. It just goes to show no single solution is perfect for every single niche task. But the overall dominance of Expanda across the broader set of complex tasks was pretty clear.
Okay, if we connect this to the bigger picture, then, a key finding from the charts, as I understood it, is how Expanda mitigates performance decay as sequences lengthen.
Yes, that's crucial.
Because traditional LLMs often see a significant drop-off in accuracy with longer contexts, right? They get lost.
They do. Their performance degrades. But Expanda holds up much better. And what's really powerful here is that Expanda can even enable smaller context window LLMs.
The ones that normally couldn't handle long texts?
Exactly. You can enable them to match the performance of much larger, inherently long context LLMs on these very long tasks.
Wow, so it's not just making big models better, it's kind of democratizing access to long context processing for a wider range of potentially smaller, cheaper models.
That's a great way to put it. It levels the playing field somewhat.
So why does Expanda work so well? Let's dive deeper into the underlying mechanisms that make it so effective. You mentioned 3 stages.
Right. Let's revisit them with the performance analysis in mind.
Okay, first, the power of dynamic chunking. The analysis showed that optimal static performance, if you had to pick one fixed size, actually occurs when the individual chunk size is roughly between 116th and 14th of the total input length.
Yeah, there's a sweet spot. And this really highlights the genius of Expanda's dynamic design.
How so?
Because it adaptively divides the input to always try and fall within this optimal range. It's not guessing, it's calculating. This leads to that 18% average improvement over even the best fixed-size chunking strategies they tested.
So it's about finding that perfect balance of segment size for both speed and keeping the context intact.
Exactly. Optimizing both processing speed and contextual integrity dynamically.
Then there's the impact of question-driven reasoning. Why is Expanda's question-driven scheme superior?
Well, compared to simply trying to directly answer the main query from each chunk, or using other planning methods, Expanda's approach outperforms by 412% in F1 score.
And why is that?
The thinking is that those explicit structured questions and sub-questions really help the agents identify and explore the context more effectively. It guides their search.
And reduces that interagent misalignment we talked about.
Precisely. They're all asking the right questions together, focused on the same sub-problems derived from the main query. It's fundamental to collaborative problem solving, even for AIs.
Okay, makes sense. Now, the efficiency of selective replay. This seemed really clever.
It is. What's truly remarkable here is the efficiency gain. The experiments showed that selective replay achieves nearly identical F1 score to the best brute force replay.
Brute force meaning just rereading every potentially relevant part again.
Yes, which is thorough, but potentially very slow. Expanda gets basically the same accuracy, but uses only 56.5% of the latter's runtime.
Half the time for the same result? How?
It comes down to its fine-grained atomic management of information states. It knows exactly which question needs which piece of information. And, crucially, its ability to determine if the currently collected information is sufficient, enabling early stopping.
Ah, so it knows when to quit searching.
Exactly. It's
What?
incredibly smart about when and what to reread, not just blindly doing it over and over. It knows when it has enough information to confidently answer and can just stop the process.
That's incredibly efficient, and all of this adds up to that overall 1.5x inference speedup.
Right. And importantly, this isn't just a one-off number. It means Expanda maintains linear complexity. Its processing time scales roughly proportionally to the input length. It doesn't explode exponentially.
Which is vital for practical use.
Absolutely. It balances inference time with the latency of making calls to the underlying LLM much better than other methods. If you're thinking about real-world applications, commercial APIs, cost per query, this is critical.
It really makes you think about the sheer volume of information LLMs are expected to handle now. How much further can we push these boundaries, do you think, without hitting entirely new types of walls? Are we nearing a limit?
That's the million-dollar question for the field, isn't it? To truly push the limits and test this robustness, the paper included a specific, very tough benchmark. It's called the dual needle in a haystack test.
Dual needle. Sounds tricky.
It is. This rigorous test is designed to evaluate an LLM's ability to find 2 distinct, semantically independent pieces of information, the needles hidden deep within a very long, distracting text, the haystack.
Okay.
And then here's the kicker. It has to use both pieces of information correctly to answer a query.
Ah, so it's not just finding them, it's integrating them.
Exactly. This isn't just simple retrieval. It really tests long-range dependency understanding, information integration, and sustained attention over vast distances in the text.
So how did Expanda perform on this incredibly challenging task? What were the numbers?
Okay, get this. A standard full-context model, just trying to read the whole thing, achieved 52.58% accuracy. Not great.
Basically a coin flip.
Pretty much.
Yeah.
Retrieval Augmented Generation, our RAG, did better, achieving 64.01% accuracy.
Okay, an improvement.
But Expanda soared to 72.53% average accuracy.
Wow, a really significant jump over both.
Yeah. This visually compelling result demonstrates Expanda's enhanced robustness. It shows it can effectively mitigate those common performance drops we see in other models, especially under really challenging conditions.
Like very extended context lengths, deeply buried information, and significant distances between those critical needles.
Precisely. It's a testament to the system's ability to not just find facts, but to read between the lines and connect information that's widely dispersed.
Okay, so to recap our deep dive today, Expanda offers a robust, efficient, and highly effective new paradigm for LLMs to tackle these ultra-long texts. It pushes past current limitations with its clever multi-agent approach, that question-driven workflow, the dynamic chunking, and the really intelligent selective replay.
It feels like a genuine step towards AIs that can truly comprehend vast amounts of information, not just skim or summarize.
Did the paper mention any limitations or future work? Usually these things aren't perfect right out of the gate.
Good point. Yes, the paper itself, as is common in cutting-edge research, points out some limitations. They're looking to improve Expanda's scalability, particularly for models that might have weaker instruction-following abilities.
Ah, so making it work well even with less capable base LLMs.
Right, perhaps by simplifying the workflow instructions or exploring even more efficient internal workflows. They also note that current experiments were limited to inputs under 1 million tokens.
Only 1 million.
Yeah. So future work could investigate performance on even longer sequences. The journey continues, as they say.
All of which leads to this provocative thought, maybe for you to mull over. What does this breakthrough really mean for the future of AI, for us? Imagine large language models that can truly comprehend entire novels, multi-volume research papers, or vast sprawling code bases, not just short snippets or summarized excerpts.
The potential is huge.
How might this ability to grasp the full context without getting lost in the middle change the way we interact with AI? How might it change how we solve complex problems or even design new forms of intelligence systems?
Yeah, what new insights, what new aha moments will emerge from AIs that can truly deep dive into the entirety of human knowledge, connecting dots we never even saw?
Something to think about.